Okay, so here we have a homework problem that a student submitted. I just wanted to mention before I get started that if you have any questions about this problem, or if you have a homework problem that you would like to see a step-by-step video solution for, feel free to leave that in the comments or to email me at the email listed in the description, and I can do my best to help you with your homework problem as well. So starting with this problem, consider the function f of x is equal to negative 4x squared e to the negative x over 6. The first step is to find the first derivative as they have here in part A. So to find the first derivative, let's take a look at what type of a function we have. We have a negative 4x squared is multiplied by e to the negative x over 6. So let's take this as the first part of the product, and this is the second part of the product, and use the product rule. So the product rule says to use the derivative of the first, and so we can do we need to do 2 times negative 4, which would be negative 8x to the power of 1, that would be the derivative of the first, times the second, which would be e to the negative x over 6, plus the derivative of the second. The derivative of e to the x is e to the x, so we first would have e to the negative x over 6, but we also have to multiply that by the derivative of the inside function, which would be negative 1 over 6. And then we multiply that by the first, so negative 4x squared. This would be our derivative, but let's simplify it a bit. We can write it as negative 8x times e to the negative x over 6, and then our negative, we have a negative and another negative, so that stays a plus. If 4 over 6 we can write as 2 over 3, and then the x squared and the e to the negative x over 6. Okay, so this would be our first derivative. So we can put this in our first blank as the first derivative. The next part of the question asks us to list any critical values. So to list any critical values, we need to set our derivative equal to 0. So 0 is equal to negative 8x e to the negative x over 6 plus 2/3 x squared e to the negative x over 6. From here we need to try to solve. So one good method of solving when you have something set equal to 0 is to factor. We can pull out, we have a factor of 2 in both terms. Let's also take out the negative. Negative 2, we have at least one x, so let's pull that out. And we have the e to the negative x over 6 is in both terms, so let's pull that out as well. So what we have left in the first term would be 4, and then because we took out a negative, this sign will change, and we would have 1/3, and then everything else is just x that's left there. So this is still set equal to 0, and now that we've factored, we can set our factors equal to 0. Let's set also the x and the negative e to the e to the negative x over 6 equal to 0 separately. So we'd have negative 2x is equal to 0. We would have e to the negative x over 6 is equal to 0. And we have 4 minus 1/3 x is equal to 0. So dividing both sides by negative 2, I get x is equal to 0. And a base raised to an exponent can never make 0, so this one doesn't give us any solutions, so we can ignore it. Moving the 1/3 x to the other side, we get 4 is equal to 1/3 x, and then multiply both sides by 3, we get 12 is equal to x. Oops, not 0, x. So here we have two critical values. We have 0 and we have 12, so those would be our critical values. From here, we need to identify intervals of increase Let me give myself a little bit more space. If I draw a number line, let me label my critical values. So I would have 0 and 12. I need to figure out what happens in between my critical values. So to the left of 0, between 0 and 12, and from 12 to infinity. So let me pick a few test points. If I pick something less than 0, for example, we could try -1. Something between 0 and 12, we could do 6, and something bigger than 12, we could do, say, 13. So for these test points, we need to find what is happening at the derivative at these test points. Let me give myself a little bit more room here as well, getting rid of a little bit of this. And move my critical points up to the top. Okay, so to figure out if something is increasing or decreasing, we need to find whether the derivative is positive or negative. So let's plug into our derivative. Let's plug in -1 first. So we get -8 times -1. E to the power of a negative is a positive, so that would be 1/6. Plus 2/3 times -1 squared, e to the, again, positive 1/6. So to simplify, a negative times a negative is a positive 8. And e to the power of 1/6, let's see if that's positive or negative. Putting that into my calculator, I get e to the power of 1/6 is a positive. That's approximately 1.18. And then, so if all of these terms are all positive, it would be another positive number. So positive plus a positive is a positive. We get a positive for this value here. So now let's try to find f prime 6. Plugging that in, we get -8 times 6. E to the power of -6/6 would be -1, plus 2/3 times 6 squared, e to the -1 again. So here we have 8 times 6 is 48, so this would be -48, and then e to the -1 is approximately 0.0. Let's call it just 4. And then plus 2/3 times 36 is 2/3 times 36 is 24. So that would be 24, and then again times 0.4. So this term would be bigger. It would be a negative overall. So this would be a negative here. And let's find f prime of 13. Be -8 times 13, e to the -13/6, plus 2/3 times 13 squared, e to the -13/6. So 8 times 13 is 104, so it would be -104 times some e to the -13/6, which is should be a positive. Yeah, it's a positive. And then plus 2/3 times 13 is 8.66. So this would be plus 8.6 or 8.7 e to the negative 13 over 6. So this negative term is going to be bigger, so this would remain negative here. So the intervals of increase is where the derivative is positive, which would just be from negative infinity up to 0, but not including 0. And the intervals of decrease is where the derivative was negative, which is from 0 to 12, and then again from 12 to infinity. But we're using the parentheses here to show that it's not including 12. Okay, so that's parts C and D. For part E, we need to use parts A through D to identify any local maximums as ordered pairs. If we change from increasing to decreasing, that would be a maximum. But if we change from decreasing and we continue decreasing, that would not be a maximum or a minimum. So we only have one maximum. It occurs where x is equal to 0, but we need to show the ordered pair. So let's plug in 0 into our original function to find what that y coordinate would be. Let me just give myself a little space. And if we find f of 0, f of 0 would be equal to, notice that we have an x in both terms, so both terms would go to 0. It would be 0 or negative 0 plus 0, which would just be 0. That would give us our local maximum would be at 0, 0, and we do not have any minimums, so we can just put NA, or does not exist, or something to that effect. Okay, so I hope this video, homework help solution, was helpful for you. If it was, please subscribe to my channel for more homework help videos, and share with anyone who you think might find these types of video step-by-step solutions helpful. Thanks.